Welcome to another unit of the ISM Exercise Set Statistics 2, this time with a unit on the goodness of fit test. Let's have a look at the exercise. The manager of a mall suspects that the number of visitors to the food court is uniformly distributed across the days of the week. Use a suitable test for an acceptable margin of error of 5% on the following dataset to test the manager's suspicion. That's the data set. We have here the data from Monday till Friday. And we want to test whether they're equally distributed. For this, we need to use the goodness of fit test because the probabilities are indirectly given with the comment that they should be equally distributed, meaning for each occurrence, the same probability should exist. So if we take a look at the data as we had visitors for 5 days. And if we sum this up, we get 5,700. So across all 5 days, the probabilities should be the same. That's what evenly distributed, uniformly distributed would tell us. So if we have the same probability or the same percentage of visitors per day, means we have 20% of all visitors per day. So here our expected relative frequencies are 20%. And what we then do to get our expected frequencies, our expected absolute frequencies, is we multiply the overall sum, the 5,700, with these expected relative frequencies of 20%. So we see here, each day we expect 1,140 visitors. Then we have what we need for our goodness of fit test. We have the absolute number of visitors, the real visitors, the actual numbers, and the expected numbers, the expected absolute frequencies. And then we're comparing them. That we're going to use a chi-test for, a chi-square test for, meaning we take the actual number of the visitors, subtract the expected number of the visitors, square the result, and divide it again by the expected number of visitors. So for example, for Monday, we would go 1,000 minus 1,140. The result is squared and then divided by 1,140. So in detail, would that look as here? We do this for all 5 days, so for all 5 categories. That's usually how the goodness of fit test is actually performed. You do the same comparison, actual numbers, expected numbers, then squared and divided by the expected numbers for all categories that you've given. Okay, if we enter these values into the calculator, we get here this in-between step and finally a result of 98.2456. This is our test statistic. Then the next step we need for the test is a reference value, critical value or reference statistic. This reference statistic for the goodness of fit test is given as chi-squared I minus 1 minus alpha. The I, that's the number of categories. So here we had 5 days, so the I is 5. So I minus 1 is 4. The error we had, the acceptable margin of error, was 5%. So we have an alpha of 5%, giving us here the chi-square value for 0.95. If we look this value up in our table of the chi-squared distribution, we find there a value of 9.4877. Okay, we have the test statistic, we have the reference statistic, so the only thing left to do is compare the two. And if we do this, we see here that the test statistic is way larger than the reference statistic. And this is an indicator that we can reject our H0 hypothesis. What is the H0 hypothesis with a goodness of fit test? With a goodness of fit test, H0 means that our given data set, so the absolute frequencies we have of visitors, actually follows the expected values, is close enough to the expected values. So in other words, it shares the given distribution. So here we tested whether it deviates from a uniform distribution. We reject H0, so we have to say it's not following the uniform distribution. So here visitor numbers significantly deviate from a uniform distribution. This then is the answer to the mall manager and the conclusion to this exercise. And I hope you enjoyed listening to it. And if you want to see more exercises, feel free to visit the rest of this exercise set or have a look at the corresponding playlist. I say goodbye and see you next time.